Hello and welcome to Unit 2, Day 2, which is on angle basics. First thing, we have the definition of a ray. So a ray is a point with a line going in one direction. So here we have a ray, and it has one end point at point A, and it goes off forever in the direction to the right, forever and ever. That's a ray. Opposite rays have the same endpoint, or they're just two rays with the same endpoint. And they go in opposite directions. Okay, two rays with the same endpoint going in opposite directions. So here we have a set of opposite rays with the same endpoint B, where we have one going off this direction and another one going off this direction. So those are opposite rays. So how we would name a ray, like specifically the one on the top, we would name it A, B, and then over top we put an arrow going one direction. That's ray AB. Now, going on to angles. So angles are made up of two rays, both going in different directions, not the same direction. So in this case, they share an endpoint P and they go off in two different directions, and that makes an angle. For the sides of an angle, those are going to be the parts that make up the angle. So in this case, this is a side and this is a side. They make the angle. So the sides are the rays. The rays that make the angle. So the vertex of the angle is going to be the end point of the two rays that are going off in either direction. In this case, it's point P. So our vertex is going to be the end point, of rays. So it's this point where the rays come together. The interior of an angle is the inside space, but interior means inside. So it's going to be this interior part. Everything in the middle of the angle is interior. So it's contained inside angle. So everything in between. The exterior of the angle is going to be everything not inside of the angle. So this is the exterior. And then the degrees of the angle is how wide it opens. How wide angle is. And that can range from 0 degrees to 180 degrees. And we'll get more into that later, but 0 to 180 is a good basis for now. If it goes over 180, it could go like higher, but we'll get to that later. So on this angle here, I want to label the sides and the vertex. So my sides are going to be these two, so side and side, because these are the two rays going off in either direction. And then this point right here is going to be my vertex, because it is where those two rays come together. And we would call this angle 3 because there's a 3 right in the middle. So this would be angle 3, or I could name it using 3 points. It could be angle. We got a Q up here. Q, and then to P to R. So Q, P, R. That's one way to name that angle, is just by tracing the 3 letters that make the angle. Or I could do it the other way, start at R, go to P, and then up to Q. So angle R, P, Q, still tracing that angle. Or we could even call this just angle P, because angle P, this is where our vertex is right at point P, so that is also another name for it. So a bunch of different ways to name the angles. These two ways are going to be your surefire way of getting it right, is just with the 3 letters. So using the figure on the right, we're going to name the vertex of angle 4. So angle 4 is right here. Our vertex is going to be the point right near it. So that would be at point U. That's the vertex. Next, we want to name the sides of angle 3. Well, angle 3 is right here. So first thing I'm going to do is I'm going to trace that angle out following the rays. Okay. And then I'm going to identify the points that make up the angle. So I've got a point W, I've got a point X, and I've got a point U. So the sides of this angle would be WX, and that's a ray, WX, going off in one direction, and then XU, that's the other ray going off in the other direction that make the angle. Okay, next, what is another name for angle 2? Angle 2 is this one right here. So again, I'm going to trace the sides and the rays and kind of follow that out. So here's one side, and then here's the other side. And then I'm going to identify my 3 points. I've got one here, and then one here. And those 3 points will make up my angle 2. So another name for angle 2, I could use naming the 3 letters. So naming those 3 letters, I'm going to start by tracing my angle, starting at X and then going to Y, and then from Y going to U. So from angle X to Y to U. So angle XYU is another name. Or I could reverse that and go angle UYX. That's another name. What's another name for angle UXY? Well, angle U is right here, or point U is right there. Then point X is here, point Y is there. So starting at U, go from U to X to Y, because that's the order that they're listed in the name. So another name for that could be angle 1, because there's a 1 there. That's another name. Or angle YXU. So just reverse the 3 letters. That's another name for it, but it's the same angle. Great. Why are angle 4 and angle U not necessarily the same angle? So on this picture, we have angle 4, which is right here. If you were to just call angle 4 angle U, we wouldn't necessarily know that angle U is talking about angle 4, because there's this other angle that also has point U there that could be referenced when you say angle U. So you want to be specific about what you're talking about. Okay, types of angles. We have right angles. Those are 90-degree angles. And they look like this, with lines going straight up, straight across, and then we have a square in the middle, and that means that that's 90 degrees. We have acute angles. They are less than, can't write. Less than 90 degrees. And they look like this. They're kind of cute and small. They're acute. And then we have obtuse angles, which are more than 90 degrees, but they are less than 180 degrees. So here is an example of an obtuse angle, very much clearly bigger than a right angle, wide. And then we have a straight angle. So this is a straight line, and it is exactly equal to 180 degrees across. So if you ever see a straight line like that, that angle is going to be 180 degrees. Great. Here we have an example of a protractor. So a protractor is a tool that we can use to measure angles. You line the vertex of your angle up into the circle of the protractor, and then line up one of the sides with the straight edge of the protractor. And then when you follow up the other one, it'll tell you what your measurement is for your angle. So nifty tools. We won't be using them too much, but if you ever want to, you can. Okay, for these angles, I'm just going to classify the angles without a protractor because I don't have a protractor, and then you guys can find the number of degrees. So first angle is angle PJM. So P is here, J is here, M is here. So we're going to trace that. So this angle is a right angle. It has a square box right here, actually on the other side, but you can put 2 square boxes if you see one, but that is a right angle, so right. Next we have angle KJL. K is here, J is here, L is here. So go ahead and trace. Oh, that's terrible. Okay. So that angle is slightly less than the 90. You can see the square there. That means that that's 90. So this is less than that. So we're going to say that this is an acute angle. Next we have, I'm going to erase some of this, angle NJK. So NJK. Trace it. That is larger than 90 degrees. So this would be an obtuse angle. It's greater than 90. And then we have PJK. So that is a straight angle, and that would be 180 degrees. So that one we can identify as 180 degrees, and we can actually identify the right as 90 degrees as well, because right angles and straight angles, we automatically know what their measurements are. It's just the acute angle and the obtuse angle that we would have to measure on a protractor. Great. Number 3, everybody look at a clock, like an actual clock, not a digital clock. Bobby was bored, so he decided to see what kind of angles are formed by the 2 arms of a clock. He looked at 6 p.m., 9 p.m., 7:10 p.m., and then 4:30 p.m. However, because he was daydreaming and not paying attention, he could not remember what the differences between a straight, right, acute, and obtuse angles are. So please help Bobby. So first, let's look at a 6 o'clock. So I drew this nice clock over here. If it were 6 p.m., minute hand would be pointing up, the hour hand would be pointing down. What kind of angle does that make? 6 p.m. is a straight angle. Next time would be 9 o'clock. So if it were 9 o'clock, minute hand's facing up, hour hand's facing to the left, pointing at 9, that would be a right. So 9 p.m. is a right angle. Next is 7:10 p.m. If it were 7:10, my minute hand would be pointing at the 2 because it's 10 minutes past, and my hour hand would be pointing at the 7. That would be an obtuse angle. So 7:10 is obtuse. And then last is 4:30. 4:30, let's see. Hour hand would be pointing at 4 o'clock. And minute hand would be pointing at 30 minutes. So that would make an acute angle. Okay. And last one I kind of want you guys to try. You're going to try to find the total number of angles made in this diagram. And I'll give you a hint, it's not 1, 2, and 3. So see how many angles you can find, and then that's it for day 2. And we'll get back to you guys for day 3. Bye.